I'm Jamie O'Reilly, and I'm going to give a quick overview of this paper published in the Journal of Neuroscience Methods. This experiment was performed to study central auditory processing. I recorded electrical brain activity from the mouse's auditory cortex while playing different duration sounds. This data was then stored in a computer for later analysis. Ten different duration tones were played. These were played in random order 100 times each, and the interstimulus interval, or time between each sound, was fixed at 450 milliseconds. These are the grand average auditory evoked potentials, and they all show a large onset response starting from 0 milliseconds, which is shown with a vertical white line. Viewing them individually, it isn't clear what differentiates them, although if we look closely, there is a pattern. This becomes clear when all of the waveforms are plotted together on the same axis. Wee positive peaks occur at the end of each sound. The problem here is, how do we quantify these in terms of their peak latency and amplitude? The first step is to compute the average waveform. You can see here in the red trace that the wee peaks have been smoothed out. This average can then be subtracted from each of the individual waveforms in turn to isolate the offset responses. Here we can see the result. It is now possible to measure peak latency and amplitude. It is also possible to synchronize these waveforms at the end of each sound. This is shown here with pre-offset baseline correction, and we can compare the responses to different duration sounds. We can see that the response is generally characterized by two positive peaks followed by a slower negative deflection. In summary, data was recorded from the auditory cortex of mice while playing 10 different duration sounds. These sounds produced large onset responses and smaller offset responses. Using simple waveform arithmetic, these offset responses can be isolated and analyzed. If you're interested in learning more, you're more than welcome to read this paper.